The strawberry at high pressure.
Yeah.
They replace the water with lemonade. It looks like a strawberry lemonade.
Oh, really?
I braid it up to the back like I usually can. I never do that. I just
Is it a perfect square? No. So what perfect square goes into 20? 4 times what is 25? All right, what about the x to the third? In order to take the square root of a letter, you got to have it even. What you got? That's part of it. And x. There you go. 2 and 1 makes 3. All right, what about the y to the 5? Very good. What about the z to the 6?
No, goes to the outside.
He goes to the outside as?
Z3.
Z3. Scotty, why are you singing in different C? It's kind of freaking me out.
That's fine. Yeah, me too.
Okay. I'm not, y'all can't switch up on me,
I
like,
can be closer to you, Miss Moore.
oh gosh. Alright, what's the square root of 4? 2. Can't do 5. What about the square root of x squared? X. Does it freak y'all out when I say that? Every time y'all stop and think about it. What's the square root of y to the 4th? Y to the 2nd. And then I'm just going to bring that z to the 3 down. And then what's left inside is 5xy. There you go. Don't worry. It's going to be on here for a long time. You just want to come Monday? Because Monday and Tuesday, all we're doing is makeup day.
Oh, yeah, that's fine.
I only say that because my 3rd and 6th period are finished with everything. They have makeup days for the next 3 days because some of them desperately need it. It's going to be craziness in here. So it would be great if you could just wait till Monday.
Yeah, well, if I don't do what we do as well.
That would be awesome.
Right.
All right, what about number 2? Do they have anything in common?
No.
No. So you can find factors of 6, which are 1 and 6, and 2 and 3. What about 49? Uh-huh. There you go. All right, so do you want to use 1 and 6 or 2 and 3? It's not a big deal if you pick the wrong ones. We'll just fix it. I know the answer to this is I can tell you 2 and 3 is going to work. Well, I don't really know the answer, but I can tell you 1 and 6 is not going to work. I can tell you that right off the bat. Because I'm trying to get to 7, right? 1 and 6 is already going to give me 7. If I put it with anything else, it's going to be over or under. So that's how I knew I couldn't use 1 and 6.
Are you smart?
No, I just done this for a while. All right, so which one you want to pick? 1 and 49 or 7 and 7? All right, well, that's pretty easy. I don't have to worry about where to put them because they're both the same. All right, let's do outer. What's 2k times 7? 14k. What's 7 times 3k? All right, how in the world, what's 14k and 21k? Give me 7k, positive 7k. There you go, positive 21 minus 14. All right, so now you got to ask yourself, how do I get to 14? Because that's where my negative needs to go.
Outer.
That's your outer. That's 2 times 7. There you go. That means the other one has to be a plus. And check your last just to make sure. 7 times negative 7 is negative 49. There you go. All right, number 3. So let's divide like we did from, I don't know, 4th grade or so. What's negative 21 divided by 3? And where's the negative 7 go? On the top. Now, this stuff is from 9th grade. You haven't done this since 9th grade. Who's at the door? Oh, that's Brent. Somebody let Brent in. Hey, Brent. All right, so when you multiply the bases, what do you do to the exponents? Yeah, add them. Ooh, kind of freaked you out, didn't I? It looks like a division, but it's not really division. They're being multiplied. All right, so there's a 1 right here. What do I do to the d to the 1 and d to the 10? Yeah, add them and you get 11. There you go. Don't touch the 9 and 11 because they don't have the same base. Kitty got it good? Wow. Oh, well, I'd rather trick you now than trick you on tests, so. Where we at? For the function g of x equals 2x minus 5, what is g of x plus 4? So what do I do with this? Plug it in for x, okay? It may just be a little funky looking, but you still plug it in. So instead of 2 times x, it's 2 times x plus 4 minus 5. Distribute the 2, you get 2x plus 8 minus 5. Subtract the 8, and you get 3. There you go, which is A. Y'all okay? All right, number 5 is a really, really easy problem. It says vehicle A averages 14 miles per gallon of gasoline. That's pretty bad. But then vehicle B averages 36 miles per gallon. They got a Prius, okay? at these rates, how many more gallons of gasoline does vehicle A need than vehicle B to make a 1,008 mile trip? So guys, all you do is vehicle A, 1,008 divided by 14. Vehicle B, 1,008 divided by 36. Yeah, I lost my number there.
44.
All right, what is this? 44?
No, it's 72.
This one's 72?
Yeah.
Okay. And what's this one?
28.
28?
Oh my God.
And what do I do to those two numbers?
Subtract.
Subtract. I mean, you want to know the difference between them, and that is 44.
Yeah.
I'm really bad at dividing in my head. Everything else I can do in my head, but dividing I'm really bad at.
That's such a big difference.
Well, that's why you get a Prius. That's why you get a Toyota. All right, so I gave you your notes on the way in, or some of you grabbed them on your way in. So go ahead and get those real quick. We have one lesson to do today. It is very, very similar to your bell ringers of number 3. That's why we've been putting them on here. D, do not worry. Factoring and radicals are not going away. So we are going to be doing them for a little bit longer. All right, here we go. Now, do you see this page right here? Okay, unfortunately, I did not realize that these were not numbered yet when I made your copy. So at the bottom of this page, just put a little number 1 so you know what page number we're on. Bottom of this page, it would help if you were on the notes with us. Yes, ma'am. You didn't get the notes?
You want us to number the right stuff?
Yeah. All right, take a minute and go ahead and number all your pages. This is page 1. Next page would be page 2, then page 3, then page 4, all that good stuff. Since we have been going over them on our bell ringers, we should be able to fly through this first unit, this first lesson pretty quickly, right? Hopefully you're numbering your pages at the bottom. Take about 30 more seconds. They look really long, guys, but it's mainly because I give you a lot of stuff already in there. It's not a whole lot of problems. It's really kind of a short lesson, or unit, should I say.
How many pages was supposed to be?
14. 13, yep. All right, here we go. So, what does this mean? Product of powers. It means that when you multiply the bases, oh crap, I just marked on there. When you multiply the bases, what do you do to the exponents? You add them, okay? That's what we've been doing, right?
Yeah.
All right, quotient of a power. When you divide the bases, you do what to the exponents? Subtract. Okay, we haven't done a whole lot of these, but we have. If you have a negative exponent. Key word here, guys, look right here. This is what always gets you. The key word is negative exponent. Some of y'all get in the habit of seeing something that's negative and you just start switching things around. If you got a negative exponent, it goes to the opposite spot, right? What's the opposite of the bottom of the fraction? Top of the fraction. What's the opposite of the top of the fraction? Bottom of the fraction, right? Power, a power. So if you have one base of x, what do you do to the exponents? You multiply them. Power of a product. This means that everything in here, what is that, an A? Is that what it says? Everything in there is to the A power. So instead of xy, you can put x to the A and y to the A. And then let's see, power of a quotient, same thing. This tells you that everything inside there is to the A power. Look right here. This one's kind of a big one. You ready? What kind of exponent is that? So where's that x go if he's got a negative exponent? On the bottom. Where's that y go if he's got a negative exponent? On the top. That's why everything switched around. Everything we've been doing, right? That's why we review it on bell ringer, so we can kind of fly through this stuff. All right, let's go to page 2. Page 2. And we're going to fly. So, if I go too fast, all you got to do is say what?
Stop.
Stop.
Where's your little? We don't have our little powers anymore. You want a little stop sign?
Oh, well, stop sign.
Oh, yeah, I know. All my little boxes messed up, so we don't have those anymore. All right, what am I doing?
I don't know.
You add the exponent. 6 plus 2 plus 7 is 15. Thank you, Brinkley. All right, so remember, make sure you subtract them on number 2 so that it's positive. Do 8 minus 2, and you get 6. A to the 6 goes on the top where the biggest one is. That is over 1. You don't have to write the 1 on the bottom, so your answer is just A to the 6. Y'all okay? All right. No, I just wrote it so you can see. Okay? All right, what about number 3? How many x's do you have? Well, 1 base, right? So what do I do to the 4 and the 7? No, you don't. When you have 1 base, you multiply. Number 1 was where we added. Number 3, there's 1 base, so you multiply. Oh my goodness, look at those negative exponents. You ready? All right, let's draw your bar. You ready? Draw your bar first. It's easy if you go ahead and draw your bar. It'll make your life easier. Because we have negative exponents, we've got to switch stuff around. All right, all of these things are over what? 1, right? They're all over 1. So the 2 can go where? Top or bottom? Top? No, he's positive, people. 2 is positive. Not the exponent. All right, where does the A to the negative 2 go? On the bottom. Wait a minute. Why did the 2 not go to the bottom? It's to the negative 2 power, isn't it? No, only the A is to the negative 2 power. All right, what about the 3? Where does the 3 go? Stays on the top. I'm multiplying it. What about the A to the 3? Where's he go? He stays on the top. What about the B to the 2? Why is he staying? Because he is positive. Where does the C to the negative 2 go? On the bottom. Alrighty.
So when they go to the bottom, it takes the negative one?
When you do the opposite position, he takes the opposite sign. Yep. Alright, what's 2 times 3? 6. Alright, what about your A's? When you divide the bases, what do you do to the exponents? And 3 minus 2 is? And it goes on the top. And I don't have any other B's, so I'm going to write him down. I don't have any other C's, so I'm going to write him down.
Where did the A to the 3rd go?
3 minus 2 is 1. When you divide the bases, you subtract the exponents. So I gave you A to the 1. We've been doing it on the bell ringers. When you divide the bases, you subtract the exponents and you get 1. All right, number 5. Here we go. When you divide the bases, you do what to the exponents? You subtract. Subtract them so it's positive. Say 7 minus 2 is how much? And where's that Q to the 5 go? On the bottom. And the R's, when you divide the bases, you subtract the exponents. 4 minus 3 is R to the 1 or just R, and it goes where the biggest one was, which was on the top. Y'all okay?
I'm still kind of confused.
Where? On number 4.
Yeah, I think I just got lost.
Let's do these other ones because there'll probably be another one just like it. So we'll do it in just a minute. Actually, number 7 is very, very similar to it. All right, here we go. Number 6. Do I have any negative exponents? Yes, I do. So look right here. This number 6 is just like this one. Here we go. This is over 1, right? All these are over 1. So draw your fraction bar. The 2 is positive. I'm not worried about the 2 because he's not an exponent, right? So you're going to leave him right there on top. A to the 3 has a positive exponent, so you don't touch him. If you got a positive attitude, your mama doesn't mess with you, right? If you're not doing anything wrong, your mama doesn't mess with you. She's not supposed to.
That's what you think.
B to the negative 2 is negative exponent, correct? So he needs to go where? To the bottom to make him positive. So now he becomes positive 2. All right, now this is it right here. You ready?
We're done with that.
With this first one, yes. This 4 is not an exponent. Do not switch him to the opposite spot. He is just a regular, down-to-earth 4. Don't touch him. He is not an exponent. The key word was negative exponent. All right, what about A squared? He's positive. Don't touch him. Leave him there. What about the B to the 4? He's positive. Don't touch him. Leave him on the top. Then I can multiply 2 times negative 4 is negative 8. Very good. All right, let's see. So I'm done with that. I'm done with that. D, it really helps, especially when I was learning these, I mark things out. So that way I don't have to look at everything. I just look at what I have left. So I have 2 A's left. What am I doing to those bases of A? You're multiplying the bases of A. So what do you do to the exponents? You add them. There you go. Make sure you listen to the question. All right, what are you doing to the bases of B? You are dividing the bases of B. Listen to the question. So now what do you do to the exponents? 4 minus 2 is 2, but where's the B to the 2 go? He goes with the biggest one on the top. What's left on the bottom? 1, but I don't have to write the 1 on the bottom, so I can just circle that as my answer.
Why did you?
All right, what about number 7? Oh my goodness, everything in those parentheses are to what power? The third. Ooh, perfect cubes. You ready? How much is 6 cubed? 216. Very good, Gracie. She didn't actually. I'm watching her. She didn't actually. I'm watching her. All right, how many bases of G do you have? No. You have 1 base of G, right? So what do I do to the 5 and the 3? You multiply. That's 15, right? All right, how many bases of H do I have? 1. So what do I do to the negative 4 and the 3? You multiply. Now I got to fix that because I have a negative exponent. So the H goes to the bottom as positive 12. G stays and 216 stays. Are y'all okay? This is why we go over this stuff on bell ringer. Please make sure you are taking advantage of the bell ringers when we have them. Now, please be careful. Negative 2 cubed is negative 2 times negative 2 times negative 2. How much is that? Negative 8. Very good. Negative 8. Man, maybe there's a reason why this crazy lady made you learn those perfect cubes. Just saying. How many, I will throw something at you. How many, because y'all don't know how crazy he really is. So where are we at? How many bases of A do we have? 1. So what do I do to the 4 and the 3? Multiply. That gives you positive 12. How many bases of B do you have? 1. So you multiply. 2 times 3 is 6. I don't have anything in common, so I'm done. Oh my goodness, what are you doing to the bases of N and number 9? No. You're dividing the bases. What do I do to the exponents? Subtract. Do it so it's positive. What's 10 minus 2? Where does it go? On the biggest one's on the bottom. Ooh, what's left on top? You gotta write the 1 on the top. You have to. You have to. 1/2 and 2/1 are not the same thing, okay? What? All right, now look, guys, don't make this difficult. You ready? Let me show you an easy way. 16 and 8 will divide into each other, right? What's 8 divided by 16? 2. Where's it going to go? Where the biggest one is. You see how much easier that is than having to find what they have in common? Well, excuse me, 16 divided by 8. Sorry. All right, Brinkley, here we go. What am I doing to the bases of M? Dividing. What do I do to the 7 and 3? 7 minus 3 is 4. Where's it go? Where the biggest M was on the bottom. The biggest M was 7, which is on the bottom, so the M to the 4 goes on the bottom. The ends cancel out. They go away. Anything divided by itself is how much? 1. So there's a 1 left on top. Yes, ma'am, and yes, sir. You got to leave the 1 on the top. Y'all okay? Okay, this is where after we've done a couple of negative exponents, y'all get like negative happy, and you try to switch everything around. Don't switch that 28. He's not an exponent. What's negative 28 divided by negative 7? Negative 4. Where's it go? On the top. And you're dividing the A, so you subtract 7 minus 2 is 5. Where's it go? On the bottom, where the biggest A was. Biggest A was A to the 7. All right, there's a 1 right here. So what's 5 minus 1? And where's it go? And you don't have anything in common, So you're done.
I like
You ready for the next one?
it.
Ma'am? All right, now look, this is where you got to be careful. You ready? Everything in those parentheses has what kind of an exponent?
Negative.
A negative. So everything in those parentheses get swapped. Okay? So the whole numerator goes to the bottom.
Wait.
All right, look. All right, hold on. Everything in here is to a negative 3 power. Everything. So everything gets swapped around first. Everything on the top goes to the bottom. Everything on the bottom goes to the top.
But I thought.
And now it becomes positive 3. I'm not done.
But you said it was positive. You don't move it, but you just move it up.
It's negative exponent.
No, like the 5.
It's to a negative 3.
Oh.
Everything is negative.
Got you.
That's what these little parentheses thing means right here.
Got you.
Okay.
Don't be Scotty.
Are y'all okay?
Yes.
Do you see how I changed it to a positive 3 now?
Yes.
Okay, now Brinkling, since everything's to a positive 3, do y'all want to distribute the exponent first or fix things? Okay, that would make me feel better too. All right, so a to the 3rd power is just a to the 3rd power. All right, look right here on the numerator. There's one base of b, so I multiply negative 6 times negative 3, or excuse me, times positive 3. Y'all freak out and it gets me all razzled.
Switch it when it's negative to make it positive.
We're not done yet. Yep.
No, you say that there's one base of b.
Well, I'm looking at just the numerator.
Yeah, but why do you ask that? Like, would there be like?
Because if there's 2 bases of b on the top, like on the bell ringer, then you have to multiply them first, or add them first, excuse me, then multiply by 3. All right, what is 5 to the 3rd? 125. I have one person that knows their perfect cubes. Yes. It's better that you do everything at one time because you're going to get yourself all lost and confused. It's not wrong. All right, what about this one? You got one base of a, so a negative 7 times 3 is a to the negative 21. And then one base of b, 2 times 3, is b to the 6. Are y'all okay so far? We're not done. We're not done. Okay, now we can fix things. All right, so D, I like to mark things out. You ready? This a to the 3 is positive, so he's going to stay right there. Y'all okay? All right. This b to the negative 18 is negative, so he's going to go to the bottom. I'm going to put my 125 in the front, and then b to the positive 18. Are y'all okay? It really helps to mark things out so you know what you've done and haven't done. All right, b to the negative 21, he goes to the top to make him positive. And b to the 6 is positive, so you don't mess with him. He stays right there. All right, how many bases of a do I have on the top? 2, so I add, and you get 24. Multiply the bases, add the exponents. And then 125, same thing. Multiply the bases of b. Here you go, dear. Multiply the bases of b, and you add the exponents, so you get 24. Oh, wait, do those cancel out?
What?
They're the same.
But they're not the same base.
They're not the same base. There you go.
Oh.
They're the same number, but they're not the same base. They do not cancel out. Y'all okay? What? What?
Hold on, let me find out where.
Okay.
No, you're confused about what things.
Bite me, Scotty.
Stop it. We are recording. Zip it. Jesus.
Never mind. I put the b to the 6 on the top for no reason.
Oh, okay. Y'all get switch happy. Like you start switching everything around. You want to do everything. Oh, Lord Jesus. All right, simplify. Here we go. We're just going to multiply. What's 5 times 4? 20. And I'm multiplying the bases of x. So I add the exponents. 3 plus, ooh, what's right there? 1. That's x to the 4. And you are multiplying the bases of y. So you add negative 5. Ooh, negative 2. Very good. Not yet. We're going to. All right, all this is over what? 1. So now bring them, we're going to put them on the bottom. Y'all okay? Alrighty. We are dividing the bases of A, so we subtract 3 minus 1 is 2, and it goes on the top with the biggest exponent. And 7 minus 4 is what? Where? Where you lost? Okay. How much? Yeah, 3, and it goes on the top of the biggest one. What's on the bottom? I don't have to write the 1 on the bottom, so that's my answer.
So you only have to write the ones on the top.
Yes. Because think about it. Think about numbers. If I had 2 divided by 1, how much is that? That's just 2, right? But if I had 1 divided by 2, that's a decimal. That's why. So if you need to write these numbers on the side so you can remember when you need the 1 and when you don't. All right, here we go. Ooh, we got to do these exponents on the outside first. You ready? Right here, you got to do that exponent, and we got to do this exponent first. All right, so bring down my 1/2. What's negative 5 squared? 25. And then A squared, A to the 4th. There you go. And then B cubed squared, B to the 6th. There you go. All right, and then it's just A squared, B squared, C squared. Y'all okay? What? What?
I saw the one with the half, yeah, 1/2, and then I saw the 2 on the outside, and I was like, oh, sweat, it's going to be 10, and then I was like, oh, wait, that's a square. So it's
Yeah.
still going to equal an odd number.
So you don't have to worry about that. You can just put this over 2 right here. And this 25 goes right here. Like that. What you got, D?
If you, okay, so number 1, you know how you distribute to the x to the third to the x?
Yeah.
And you got x to the fourth?
Multiply the bases, add the exponents.
Yes. Why didn't you, on number 3, doesn't A, B, and C have exponent of 1?
They do.
So why wouldn't it be?
Because I have to do this exponent first. I have to distribute that 2 in there first. Make them all squares.
Oh.
Then I can do what you're thinking. That's our next step. All right, you're multiplying the A, so 4 plus 2 is 6. You're multiplying the B, so 6 plus 2 is 8. And you only got the 1 C, and you don't have anything in common, so you leave it alone. It's over 2 right here to make it simplified. Because remember, this is really 25 times 1, which is just 25 still. All right, number 4, 1 base U multiply 5 times 4 is 20. There you go, and you're done. All right, number 5. Okay, don't worry about finding what they have in common. 21 will divide negative 7, and that's negative 3, and you just put the negative 3 down there. Don't freak out about where the negative was to start with. It doesn't matter where the negative goes, right? Are y'all okay with that? All right, let's see. What about the x's? You got 2 x's that you're dividing, so you subtract them and you get 2, and the biggest x was on the bottom. All right, what happens to my y's? They cancel out. They go away. Don't you put another y there. They're done. And your z's, you subtract them and you get 2, and it goes on the top with the biggest exponent. Y'all okay? All right. Ooh, y'all don't get trigger happy here. Don't switch this negative y. He is not an exponent. Okay? You leave him right there.
Whoa. Wait, never mind. I have to negative.
Yeah. All right. So 3 minus 2 is 1, and that y, so the 1 goes on the top, and bring that negative down. There's a this is a negative 1 right here.
Okay.
And same thing, z to the 5 and z to the 3 gives you z to the 2. It's over 1, but I don't have to write the 1. So I'm done. Are y'all okay? All right. What's 18 divided by 9?
2.
And where's the 2 go? Where the biggest one was, on the top. And 7 minus 5 is 2. It goes on the top with the biggest exponent. Let's see. 9 minus 5 is 4. The b to the 4 goes on the bottom where the biggest one was. And 5 minus 3 is c squared, and it goes on the top. I don't have anything like, so I'm done. Oh my gosh, here's a negative exponent like we just did. You ready?
Well, you switch everything.
You switch everything. Everything on the bottom comes straight to the top. Don't mess with anything. Just switch their places. Switch him on its head. And everything on the top goes to the bottom. Don't mess with anything. Don't mess with any exponents. But now that -2 for everything becomes a +2 for everything. Y'all okay? Alright, you want to square everything first?
Yeah.
Alrighty. So x squared just stays x squared. And I multiply -4 times 2 is -8. What's 4 squared? 16. I have one person that knows that. Lovely. Let's see, what is that? -2 times 2 is x to the -4. And 3 times 2 is y to the 6. Multiplied everything. -2 times 2 is -4. 3 times 2 is 6. Oh. Alright, we got to switch some things around. What about the x squared? Does he stay or move? He stays. What about the y to the -8? He moves down to the bottom, making positive. Let's see. Let's see, I got 16. What about the x to the -4? He goes to the top. And what about the y to the 6? He stays right here. Multiply the bases. What do you do to the exponents? Add them. 2 plus 4 is 6. And on the bottom, multiply the bases. You add the exponent. 8 plus 6 is 14. You don't have anything like, so you're done. We got one more page and then we done.
Wait, how do you...
Aren't you thankful that we put this on the bell ringer and we review it slowly instead of all at once? Yes, that's why we have bell ringers. Some of you should take your bell ringers a little more seriously. Yep. We gotta do this whole section. Page 3 is right here. Does it have anything on it?
This part. Why do they always say be there, be square?
Because you won't be around.
Because you're
You
not
won't be around. Alright, where are we at? Okay, we did this in Algebra 1, especially if you had me. I know you did it, but it was kind of one of those things that we kind of skipped over pretty fast. We did it really fast, and it's kind of something we're going to do a little fast here. So let's read over this a little bit. You ready? So it gives you an example right here. Determine whether each expression is a polynomial. If it is a polynomial, state the degree. The degree is normally the biggest exponent, but we're going to talk about this. So here we go. You see this right here? Huh?
You know, the Celsius Fahrenheit.
Very funny. All right, here we go. Let's see. This expression is a polynomial because each term is a what?
Polynomial.
No, monomial. You should know from science that mono means one. There is one term. Wait a minute. That looks like a bunch of different terms. No, there's not. All this stuff is being multiplied together, right?
Yeah.
That is all one term right there. And then 8x to the 5 is being multiplied together. That is all another term. So you got two monomials there. So the degree. So how do I find the degree? The degree is the first term, which is 4 plus 3. Where did I get the 4 plus 3? Remember I told you it was the exponents. Y'all okay? 4 plus 3 is 7. The degree of the second term is 5. So which one's bigger, the 7 or the 5? So we say that the degree, I'll highlight this so you can see it. The degree of the whole thing is 7. Huh? No. You just find the biggest one. So look at what?
How is that the base of, I don't remember like how you
What's 4 plus 3 of this first one?
Well, yeah, but they have different bases, so how do you
I know that we're talking about degrees. We're not actually adding them together. What's the degree here? 7. What's the degree here? Which one's bigger, 7 or 5? 7. That's why we say the degree of the whole thing is 7. All right, let's look at 24. What's the biggest exponent? First of all, do you have any exponents that are being multiplied together? No. So what's the biggest exponent? So we can say the degree is 2. What does the degree tell me? Oh my goodness, what does the degree of 2 tell me the graph is going to be? We just did 2 tests on this. What? A parabola. Thank you. Goodness gracious almighty. Let's see. Alrighty. Let's do one more of these and then we'll say, I think I'm throwing too much at you. We'll save the rest of it for later, okay? Do you have any exponents being multiplied together? No. So what's the biggest one? 3. So degree is 3. This is a graph you haven't learned yet. The graph, it looks like this little curvy thingy. I call it the nene graph because that's what it looks like. So it's what it looks like, and it's the only way you'll remember it. So we'll do the other ones later. All right, your homework. You ready? Oh my gosh, yes, you have homework over the weekend.
Oh my goodness, this is
Oh my gosh, your homework is page 4.
wow, that's a lot.
I know.
That's true.
Yes, we will be turning this in, people. We will be turning this in.
Yeah, right.
Now, number 1, what's the only thing... I'll wait. You ready?
Yeah.
What's the only thing you're doing on number 1, guys? You subtracting like terms, okay? What's the only thing you doing on number 2? You adding like terms. Number 3, you subtracting like terms. Number 4,
A lot of stuff.
you combining like terms. Y'all okay?
Yes, ma'am.
Don't forget about these fractions. You know how to add fractions. Number 6, you just add and subtracting like terms. Number 7, you just distribute, right? Number 8, you just distribute. Number 9, you just do what? Foil. Number 10, that is not foiling because there's not 4 terms, there's 5 terms, right? Okay, here we go. You ready? I'm going to help you out. Distribute the x to all 3. Then distribute the 1 to all 3. Then combine. Same thing on number 11. Distribute the 2n squared to everything. Distribute the -3 to everything. And then combine. Same thing on number 12. Are y'all okay?
Yes, ma'am.
Oh my goodness, if you have a question, what can you do?
Email you.
Email me, or what else? 0 period. We will turn this in on Tuesday. Yes, you could turn it in after Thanksgiving if you would like, but it will be a 0 in the computer until you get it into me. Everybody okay? Alrighty. So what is happening on Monday and Tuesday? Makeup days. Be here or be square. Because you're not around to do your makeup work.